Okay.
Yeah, same.
Okay.
Your line.
Yeah. So the screen thing you said sharing and then no, I'm saying to write things. You said no, I have to go there and do it. Okay, and if required. Hello everyone. I don't know how many of them have joined here. Is it possible to see? Three. Three. How are the questions on the portal? They keep asking you often.
Yes.
Or you Allah,
Yes.
you're able to answer them.
Yeah, there is one question still, so we can. Just visible. It is basically this question. So there is a question here.
Probability density for a particle to be between x and x plus dx.
This is the wave function.
Mm.
And they are asked to find out the probability density. So
Mod squared of.
yeah, mod square of that.
Yeah.
So like we provide the solution. So just doing the mod square like psi star psi. So the question is that like he mentioned that like if there is a argument. So this is the question. So what he's saying over there. So he's saying that
If you have any questions, please type, okay? Then we can start answering. I'm just looking at whether there is any questions on the forum which we could answer in the meantime. Yeah.
So he's saying that like if we do the mod square, so there will be this term will come like then
Twice A B cos.
also. So he's saying that like this will come only if A and B have the same argument. So if they have some arguments are different, so
correct.
yeah,
Right.
yeah.
So that's true. That I.
So that's the thing on the.
You have replied that it is correct,
no,
right?
So
this you can reply. Yeah. You assume that it will be actually A B star plus B A star.
Yeah.
With this appropriate difference of this. Yeah.
And on the live injection column, there are these questions.
Yeah, node theorem. Okay. So let us see whether we could explain the node, number of nodes. Is that the question, right? So one of the questions which people have asked. This slideshow. This is not moving out of the way. Okay. Screen is. Yeah. So harmonic oscillator. Let's take the simple system of a harmonic oscillator. 1D harmonic oscillator. You know that there are only bound states possible here. It satisfies all the bound state conditions. And ground state has nodeless, right? Correct me if I'm saying something wrong. So ground state is nodeless. First excited state has this x times e to the minus alpha x squared. So you do see at x equal to 0, you have a node. Okay. Then it has to be symmetric. Right?
Right.
So then the question is, if you go to second excited state, will the number of nodes increase? Number of nodes be same? All these questions can be asked, right? But what you want you to understand is that when I cross here, what is d by dx? Okay, d by dx is like a momentum operator. So to be very precise, IH cross d by dx is like momentum operator. Okay. And as long as you get something momentum will start becoming at every time when you cross from this positive to negative, the d by dx is going to have a non-trivial contribution. Okay. If you want to if you don't want this to happen, you should be nodeless. That's why the energy is given by p squared over 2m plus v of x. So if it is nodeless, it is more or less dependent only on the potential energy. If you have nodes, then the px is non-trivial, so it will start getting kinetic energy contribution. If you have two nodes, then you will have one more corrections due to the other node and so on. Okay. So in that sense, you know that as you increase the number of nodes, the energy of nth node will always be greater than the energy where there is n minus 1 nodes. So in this way, you can argue that for bound state systems, the number of nodes will increase, okay, as we go from first excited state to first excited to second excited
Pilot.
and so on. Okay.
Right.
So this is another way of seeing it. Of course, numerically also you can do this and show that nodeless states are always a symmetric state because ground state will always be symmetric. And when you go to the excited state, you start seeing that you necessarily will have nodes. Okay. So this is what you are probably asking and we are trying to answer. Yeah.
There are some questions for that.
It's coming? Yeah.
Spike. So my question is that is the course on SWAYAM currently running quantum mechanics 1 is it is sufficient amount of quantum mechanics required to study quantum field theory?
Yeah. So quantum mechanics 1 is the course where you assume wave function formalism and we take up Dirac bracket notation and the basic systems where you use this Dirac bracket notations are being explained, including some aspects of angular momentum. But if you want to take off on quantum field theory, the next level which one should do is perturbative analysis in quantum mechanics and scattering theory in quantum mechanics. What is quantum mechanics? Quantum mechanics is a single particle physics, and that single particle does not disappear at any point in time. It is somewhere in the space, but it will not disappear. Okay. But quantum field theory is something where you can look at beta decay, for example. You all know what is beta decay. The neutron decays to a proton. So the neutron quality has disappeared. Okay, the neutron itself has disappeared and new particles have emerged. So if you want to study such kinds of processes where some particles disappear, new particles emerge,
Like
you can't.
electrons and neutrons are new particles.
Correct. Electrons are new particles, antineutrinos are new particles, but the initial neutron has disappeared, right? Whereas when you do particle in a box, you know that that particle is somewhere inside the box. Right. Suddenly that particle will not disappear, right? We always use that probability is always 1. So for quantum mechanics, you always look at a single particle physics. You can do two particle physics. Like hydrogen atom problem is actually an electron-proton interaction. Proton is in the nucleus. You have an electron-proton interaction, but you can reduce that problem in the center of mass system as if it is a relative coordinate and electron is not disappearing. Electron is controlled by the potential due to the nucleus. That's the way to view this. So you can treat electron-proton as, not positron, just electron-proton going to electron-proton. This is also a scattering process. And this process can still be handled within quantum mechanics. You don't need to go to quantum field theory. Of course, you can do this problem also in quantum field theory. But quantum mechanics is good enough to solve such scattering problems where you treat that the electron, we are studying single particle physics of electrons moving under the influence of the potential due to the nucleus. That's the way we look at it. So quantum mechanics 1 is very important to learn. Quantum mechanics 2, which is the next level course, which is involving perturbative theories, variational methods, because not all systems are like harmonic oscillator and hydrogen atom. You need to know how to use some other tools like perturbative analysis to understand how to find the energy spectrum, what will be the correction, and so on. And then this tool of single particle quantum mechanics can be extended for situations like particle, the beta decay things which I was saying, where you need new particles created, single particle has disappeared, and so on, where you need quantum field theory. So I would not say that whether this course itself is sufficient. Try to do perturbative analysis and then take off on quantum field theory. Whereas a warm up in quantum field theory, you can understand some of these processes, two body scattering processes, and then you can take up. Okay. Yeah. Quantum harmonic oscillator. What is the question on quantum harmonic oscillator? You will learn quantum harmonic oscillator in this course, probably in another 2-3 weeks later.
What exactly is question like? You ask like the question is that how to distinguish between classical and quantum harmonic oscillators, or like see Sanat.
Sanat is asking quantum harmonic oscillator. What exactly is the question is not clear. This is a quantum mechanics course where you will see that the energies, there is a 0-point energy, half h cross omega, which is coming from the quantum aspects, quantum fluctuations can lead you to get this half h cross omega, and this can be systematically. So this is what will be your ground state energy. Okay. Whereas if you had in classical physics, you would have said the ground state energy is 0. And we need quantum mechanics where you can show that the ground state energy is non-trivial and going to be half h cross omega. We will see this towards another 2-3 weeks later. You will see the quantum harmonic oscillator coming. Yeah.
Who can we take this question?
Yeah. So there are some general questions which is asked in the Google Sheet about.
Yeah. So the name. So this is Sital. She's asking that. Can you please tell us about future opportunities after a PhD in quantum mechanics?
See, you see that the current trend appears quantum technology, quantum computers, they're all based on concepts of quantum mechanics. Okay. So in that sense, I do see that the world is going to be more governed by quantum physics. Okay. Yeah. So those are things which is going to be very topical. And of course, you can take directions for all the microscopic physics and particle physics, the God particle, all these things would not have been explained unless we do quantum aspects. And because particles disappear and particle appear, you do need a quantum field theory, and that is what is well known in the literature as standard model. Okay. So in some sense, quantum is going to be for a microscopic world, right? And recent developments, okay. One is, of course, as I said, quantum information, then you have quantum computing, okay. So these are very topical areas where you need to be a little bit knowing all these tools of quantum mechanics. So this course is just a tools, not applications. But if you know the tools, you can get on to looking at topical areas like quantum information, quantum things. But there are other things which is my kind of interest is going to be on mathematical physics, which depends on a special class of field theory called topological field theory, okay, which captures the topology, geometry of many math problems, where a lot of interesting developments are happening. It's sometimes nowadays called as quantum topology. Okay, if anybody is interested, can take a look at some of these things. Of course, quantum is very important in particle physics. Okay, lot of developments, Large Hadron Colliders. Now, the Higgs particle was detected there. All of these things are hinged on a quantum field theory model, which is called standard model. Now, a lot of developments are happening beyond standard model.
She's asking about like the future opportunities.
Physics. Huh?
She's asking about.
No, I'm saying topical. So,
Okay.
which is also future things are going to, it's not going to stop
Right.
now. So they are all very topical, and things are, lot more things are going to come up, and I'm sure you people will have. So the thing is, I consider all the students as completely unbiased, who are not, who are all fresh minds, who can relook at many problems where we don't find a solution. You may find an angle of approach where you might find a solution.
Right.
So the courses which are done here is just the tools. You should be able to use them and see whether you can try and understand why nature behaves this way, what can be explained, and so on and so forth. So this is where you need to start introspecting and looking at many things from the research mind. And all these courses are basic courses, and it will help you to get onto any of these topical areas of research. Because somebody is asking, will there be so this is what I meant by my bit of research. And then someone is asking, will there be any class on random matrix theory? Incidentally, what is this random matrix theory? You can ask. I don't know whether there are classes.
Right.
But I had written an article in Resonance, probably 2010, maybe. You can search my name and see. This is complex systems. Physics of complex systems, how to use random matrices, theory of random matrices. Okay.
Yeah.
So basically the zeros of the zeta functions, all these things can be explained. Just like you know how to do integrations of functions. If you promote them to matrices, okay, then what this becomes is matrices. Okay? And these have very rich structures, very rich. So it's just an integration of matrices. And these matrices are not dependent on any position or anything. If you start putting position dependent, then those matrices will start giving you quantum mechanics of matrices. If you start putting X, Y, Z, and T, then you can start looking at them as gauge theory, quantum field theory. So in some sense, the theory of random matrices are very interesting. If you see this resonance, I don't remember exactly the year, but you can Google search and check it out. And I have given a couple of references where a lot of applications of random matrix theory on many other interdisciplinary problems can be handled. So if you're interested, you can take a look at them. Okay, and some references are also there. Ma'am, do you recommend purchasing Intro to Quantum Mechanics by Griffiths for the Swayam course, or will your slides and videos and assignments be sufficient for full understanding? See, the thing is, slide, I am centering around Griffiths and Sakurai, but if you really need a book as a background to look into it, if you have an access on a PDF version of it, you can take a look at it just as a supplement. Some good quantum mechanics book as a reference book, if you have it by hand, it is always nice. If you have an access to a library, then you can always go to the library and refer to it just to supplement whatever I'm teaching in the course. Okay, but it's just for you to reinforce whatever I've taught is understood and so. Okay. But otherwise, you really don't need to purchase it. Periodic boundary conditions and rigid boundary conditions. Okay. Periodic boundary conditions is like if you take a particle in a circle, okay, then you're forced to say that the function, suppose theta is the angle by which I can represent all the points are different theta. So this is theta equal to 0, this is theta equal to pi, and these are various points in theta. So when I say theta psi as theta, periodic boundary condition or single valued natures of your wave function, that theta plus 2 pi, right? If you go over the circle by integer multiple of pi, you can't get a new wave function. Then the single valuedness is lost.
Right.
So if you want the single valuedness to be preserved, then you put this kind of a periodic condition that whenever you rotate it, you can also have tiles in your room where whatever happens here, then you put a periodic boundary. It depends on the situation, that if the physics is going to be same in this first tile, repeated again here, then you can put a periodic boundary. Rigid boundary conditions, there is no such periodicity. You have a particle in a box going from 0 to L, no periodicity, but you put that here there is infinite potential. So you need to put rigid boundary conditions. So it depends on what exactly you're doing, where you have to apply, and then accordingly apply. Is that okay?
There's a new question.
Yeah. And ma'am, is there scope for theoretical research ourselves, or is it a complete theory? There's still a lot of scope, lot of young, fresh mind to look at many things. We need people. Okay. So nothing is complete. Okay. Every time something is trying to get completed, new things starts opening up. So at least this is my experience for the last 30, 40 years. So you should be able to get, basically you have to look out for what are the kinds of things happening. Is there somewhere where you can use your tools and use your imagination, use your, research spirit to find something which will be really, cutting edge breakthrough work. All of you have that potential. You just have to kindle. Okay? You have to work on it. It should not be just saying, oh, she taught me, I know this. Will she teach me this? No, that is not the way you should all look into it. You should try and learn. I know these tools. Can I see where it is applied? or if someone is saying this applications, then you can see from your own perspective of what tools you have learned, can you cook up and understand it from your way? In the process, you might find some new results, which is logically correct. And then it may lead to new things, right?
No.
Is that answering you, Sheetal, Ablani? Nothing is complete. Now people are looking at beyond standard model, new physics beyond standard model, right? So still people don't know whether supersymmetry is still going to be seen or not. So a lot of things are unclear. Even in the mathematical physics, there are many open problems where people have to find ways of finding some tangible solutions. Now, many of us have been thinking whether we could use this current, fashion of, I won't say fashion, it's becoming like very important. Neural networks, machine learning, and, artificial intelligence. Is there a way in which we can use those resources to validate many of the conjectures? Whether we could do something to validate those conjectures, prove or disprove those conjectures. All of us keep a lot of, the Nobel Prizes this year. Most of them went for, yes, applying them and validating them.
Right.
And it appears like many of these tools also one has to pick it up now, given the lot of interesting developments. Because in our lifetime of 100 years, we can't do so much the way the computers will do it.
Exactly.
So this is one thing which people feel, that if you want to generate trillions and trillions of things to validate something, then you need this intervention. Okay? Yeah. So there are a lot of scope. So there is nothing, you need many brilliant minds to get in. Yeah, ma'am, will hydrogen atom be covered from scratch in the SWAM course? My understanding of spin and angular momentum is not very good. Should I go back and learn, or see this word of covered is something which I always keep telling all my students. So the course is to uncover things, okay? So no covering up. So this is very standardly used by many teachers, even in school. I will cover the syllabus and so on. Essentially, you will learn about hydrogen atom, you will learn about spin and angular momentum. But if you still find that what is being discussed in that lectures, you can always get back on the live session and ask me, and I will try to answer. Okay. And are there any open source projects we can contribute? At the moment, no. But there is some provision by NPTEL where they do allow the toppers, when you take the exams, and the toppers are allowed to do a summer internship or a winter internship for a month or so. So
this is the question, like most of the
so if they do very well, if they do very well, then the NPTEL office sends me the list of names, and I do take 1 or 2 students.
Right.
Some of them like to come in person, and only issue is about finding hostel rooms, which also we find. And last December, there was one student who came for summer in the winter internship.
Right.
So you are welcome. You have to be on the topper list.
First focus on the course. So
So
then LPTL will be inform you, like send the list.
Yes. And then you have a chance of coming and doing some kind of a reading project or hands-on on some research related projects, depending on how motivated and how much you are pushing me.
Right.
I typically see the students when they interact and they come back with various questions. Then I start thinking, okay, this problem is interesting. Maybe the student can do this, do that.
Right, right.
So all of these things are, doesn't go like a straightforward way of saying, okay, if you come, you'll definitely do. It all depends on your motivations and your interactions, and sometimes interesting works happens. Okay. Yeah. But I'm not taking any open source projects or anything at the moment during the semester. Okay. This is either during winter or summer internship where I do take one or two students. Okay. Yeah. Any other question they had?
I think you missed that one. Willia Tom.
Will there be any way to correct what at times ChatGPT cooks up based on data, especially in theories related to quantum mechanics problem solving? See, the thing is, ChatGPT, I somehow feel these ChatGPT and all these Googling are okay, but sometimes you get wrong informations.
Yeah, most of the time.
Yeah.
Yeah.
So I would say that it's like, if I'm not a medical doctor,
Right.
and I find a report in my mailbox, some blood test report, if I use Googling, it starts giving me all kinds of answers.
Right, right.
But it's better to
Answer.
not so much, focus on all those Google answers or ChatGPT answers. But if you have a background,
Yeah.
if you have learned this course and you are asking similar questions and it gives you garbage, it is garbage.
Garbage, yeah.
Okay, so somewhere you can use ChatGPT as some kind of a validation of what you know, or say that it is garbage or not, and so on. So in some sense, you can mix and match with ChatGPT.
Like ChatGPT is also in an experiment, like they're doing the experiments, like.
Yeah, I agree.
Right.
But sometimes, I know that suppose I want to write a small algorithm for a factorial.
Right.
Earlier days, I used to type it out.
Right.
Now, if you ask ChatGPT, it types out you a small program.
Right.
If you cut and paste, it does do it.
So, but
So,
for that you have to know, right?
Yes.
Like what is the
Yes.
correct or wrong. Otherwise,
Yes.
like
Yes.
it will provide anything like
Yes.
which is
So
not relevant.
you should know that when I run this, if I do 15 factorial, what should be the answer? 5
Exactly,
factorial, what is
exactly.
the answer?
Right.
Is it giving the same?
Right.
So in some sense, you can use mix and it's like calculator. If
Right.
you want to multiply 10 digit by 10 digit,
Right.
I rather do it on a calculator rather than doing with pen and pencil.
Right.
So you can mix and match ChatGPT given the availability, but you should not completely rely on it. Okay. You have to have your basics learned from the good sources, and then you can supplement for some validation or disprove. Okay. Most of the times the answers are wrong, but we realize it only after we learn it in this class. Yes, exactly. I hope I clarified what I am saying. Okay. So don't completely be. Nowadays, most of the students think, online ChatGPT is there. We don't even assignments. If I give, they think ChatGPT can solve the assignments. But some of the things they write, I know that they don't understand. So you need to make sure that you don't rely on ChatGPT. Okay. If your concepts are correct, you can try to use it to check whether ChatGPT is saying it correct or wrong. And so. Yeah. Any other question? Internship thing I've answered.
Yeah.
What else they asked? Anything else?
Yeah. So she asked the same thing. Like, what is the currently trending topics in quantum mechanics research?
Yeah.
And internship, and then future opportunities. So this is the no questions also done. So there are two questions. So there's another question.
What topics would you recommend for someone with a computer science undergrad who wishes to contribute to theoretical physics research? I think if you are a computer science undergrad, you may have a lot of handle on complexity, and so on, right? Maybe you should involve yourself in these quantum computer kind of works which are going on. That's one direction where you may have enough background to get on to those topical research on quantum information, quantum technology. Okay. I don't have any other way of looking at. Sometimes at some point I was interested in looking at complexity issues, whether it's satisfiability problem, three satisfiability problem, and so on, to understand many of my issues in knot theory. So there's a lot of interdisciplinary overlap which happens between various disciplines, computer science, math, physics. And the tool like quantum is actually very useful for you to appreciate better. Okay? Yeah. Anything else? How many students are registered in this course?
For example, I think there are
Exams still yet to decide, I think. They still have time, I think. But formally, probably some 1,000 students or more. Yeah, you should take, if you are trying to do these courses on the NPTEL, you should take it seriously, doing your assignments, submitting your assignments on time, and taking up the exam. All of these are very important. If you want to understand a course properly, you have to put in a lot of effort. Okay. Yeah. I have deep interest and want to work on core theory of quantum mechanics, the framework, etc. Which branch and institute can I target? Please suggest. So you are doing what? Final year student? Okay. Are you a final year BSc student or something that you are asking? Bharat? Who's Bharat?
there are one 1200 enrollment.
MSc final year. Okay. Very good. So you should try and write all those GATE, CSIR, UGC NET exams. If you are interested in doing research in physics, core theory of quantum mechanics, there are many fields which are there. IITs, ISERs, the research institutes like Tata Institute, HRA, Harish Chandra Institute, they all have a separate exam called JEST.
Right.
So you should start writing them, look for the deadlines, apply and write those exams. Then take it up for research. Yes, quantum entanglement is also important. Okay. So many things classically, you don't have such possibilities. You name it, there are new things which are counterintuitive in the quantum scenario. One of them is the entanglement. It has rich information. Okay. So there are teams in quantum information theory where quantum entanglement plays a key role. So you can get onto any of these research areas. Yeah, all those freedom you have, you don't need to at the moment decide which one you would like to choose. You can always get on to a place and then start interacting, figuring it out, whether you want to go into basic aspects, more in depth on, you know, pure science aspects or application aspects. All those things you can decide. Don't need to so much think at the moment. Okay. So whether you want to work purely on theory or applications, at the moment, please don't too much think. You never know. And you get in and start interacting with the professors, you may find something exciting. Okay. Today, you may say, I don't like this, I don't like that, I want to do this, I want to do that. When you start getting on to, of course, you can decide, I want to be in, this area as a broad area. Don't get into so much into narrowing that area. So, okay, you like to be in quantum mechanics, of course, you can decide all those things. But within that, I want to be only in theory, not applications and all. You can leave it at the moment. I think you should wait till get yourself hands-on, interact with people, and then things will all take its path. Okay? So don't be so much, don't have the strong thing that I want to only do this. Right? Keep some bandwidth.
Right. Open.
Some bandwidth. I'm not saying too much.
Right.
Finally, you are the best judge. You have certain flair, you have very good intuition, you have very good mathematical. There are some students can actually see the problem without doing the things. No, according to this, I don't expect this to be a solution. Whereas there are some students who will say, no, I don't understand what he's saying. Let me do the calculations. Let me see what is coming. No, there are various ways in which each person knows to tackle, depending on what flair they have.
Exactly, yeah.
And each one is correct.
Right.
You should not violate so much. Oh, he is doing it that way, I would like to do. You do the way you would like to do it. But keep your boundaries slightly with little bandwidth so that you are hearing and discussing with people. And in the process, you will figure it out. This is a nice problem that I can get on. I can sort it out. And I will work it out. Okay. And you'll have some guidance from the advisor. So you'll be able to do things what you are passionate about. Yeah? Is that answering, Bharat, your question? Okay. So what is quantum entanglement? Somebody is asked. I would like you to, I don't want to get in here telling about what is quantum entanglement. Basically, if you take two systems, the two systems could be, separate. That you can have superposed states here, superposed states here, but if I write as a two system thing, it will be a product of superposed state of system 1 times product of, superposed state of system 2. It will be just a product of. That is unentangled. Okay. But there's something called entangled, where something which you do here will affect this. And you cannot write the state as product of system 1 times product of system 2. It will be a combined one, which is called this. I'm sure you would have, if you have seen some of the lectures on quantum information, something called Bell states. So Bell states are completely entangled, maximally entangled. There is no way something which you try to do it on system 1 will affect the system. The simplest example is the two spin particles in a singlet state. you know that if one particle is spin up, the other particle has to be spin down, or vice versa. So measuring here, automatically you know what is the information on the other system. In some sense, completely intact. So these play a lot of role in these entanglement issues, are something which is very important in quantum information theory. So I don't want to go too much into detail, but there are a lot of applications. Any other question you have? Of course, incidentally, Bharat, if you really want to be on a theory part, there are also a lot of work on particle physics, phenomenology, where you need the concepts of quantum.
Right.
So you could get on to those neutrino physics, particle physics, collider physics, which are under the broad title of particle physics phenomenology, where the quantum aspects will be useful. Of course, condensed matter systems, I did not get into it, but because my area is mostly energy physics, but condensed matter systems, a lot of other systems where you could do theory using your quantum tools. Okay. Any other questions any of you have? So please, whoever is a weekly ones, of course, assignments you people are submitting. And exam writing is also important. If you have any questions, you can put it on the forum. Of course, weekly, monthly ones, we will meet here on the live session. And if the time is suitable or not, you can check with them and you can book the next slot well in advance.
Right.
Probably early March, we can have one more session.
Okay.
Just check with the students. Is this time okay? You can take a call and see whether they are all okay. Majority. You can't go by everybody's decision.
Okay.
And if the slot is available in the studio, we can fix the live session.
Okay. Yeah.
Okay. Okay. So if you don't have any further questions, so how far they've come till now in their courses? 3 weeks? What all they have
3
done?
weeks. Yeah. 3 weeks.
So they have done linear operators,
Yeah.
Hermitian operators.
Yes.
Okay. And they are ready to do the measurement things.
Okay,
Compatible.
Yeah.
Okay.
This week. Yeah.
Thank you. I'm glad that all of you are participating and asking your questions. See, unless you people ask me questions, I don't know what exactly know what is in your mind. So in that sense, I'm very happy that most of you came here and asking questions. You should come, all of you should come, more people should come and ask questions. Even if we take more time, we should be able to answer all your questions. Put it on portal. Actually, I wanted to target particular institute and exam related to my core theoretical interest, especially the bridge between maths and physics. Yeah. So, Bharat, there are many institutes which works only on the theoretical interest. I told you, Harishchandra Institute is one. Institute of Mathematical Science, Chennai Mathematical Institutes. And of course, TIFR has experimental component, but you can apply to the theoretical group, theoretical physics group. And all IITs also have theoretical group besides experimental groups. ISAs also have theoretical and experimental. So these are many of these important universities, okay, important institutes, research institutes. But if you are interested in, specifically like a person or somebody with whom you would like to work, Best is to go and write that specific exam or face the interview in those relevant institutes. And if you get selected, then you have a good chance of working with that person. Okay. So now with all this Googling, you can search all over the country in what interest area in which people are working. And I would say that if you write to them at the moment, they will not listen to you because they get millions of messages from all over the students from all over the country. But try to apply to those institutes for your PhD, face the written exams, interviews, and you will be able to achieve what you would like to do. Okay. I hope that answers your question. 3 weeks?
No, so she was replying like how much content was released.
Yeah. 3 weeks are over. The
Right.
4th week is
Yeah,
started. Right?
right.
So another 4 weeks from now, we can meet them. So
Yes.
that way they'll be slightly above the middle of the course.
Right.
And then they can have more questions to ask us. Okay. Okay, so should we sign out? If you have any other quick question, you can ask. Otherwise, I assume we can meet again 4 to 5 weeks from now, early March maybe.
Yeah.
Okay. But take that time, convenient time, so that many more students can join. Because I see very handful of them here present. Okay, see you then. Bye-bye. Bye.